Dr. Andrew Marks, who's going to address first the research aspects of our work on human security and geospatial intelligence at USC Special Science Institute. And then Steve Fleming will talk a little bit about the teaching and how the research and teaching really kind of come together in our online programs. So Andrew, with no further ado, take it away.
All right, well, thanks, Bob, and thank you, Virginia, for the nice introduction. You know, what I want to do for the next 10 minutes or so was to use my time to explain some of the active research that we have, which gives a flavor of what some of our students work on, and, you know, just the breadth of different research partners and research that we're conducting, and some of the opportunities that it affords our students. So Dr. Fleming and I run what we call the Human Security and Geospatial Intelligence Lab. And this lab is dedicated to the use of using spatially explicit data to reduce human suffering, to address issues like mass migration, human rights violations, humanitarian emergency relief, you know, these kind of difficult issues, but all spatially explicit. We work with several partners, or you could also call them clients, depending on the relationship that we have. Some of our strongest ones this year have been Human Rights Watch, Physicians for Human Rights. We work with Planet, which delivers small-sat-based satellite imagery of the entire world every day. And we also work with a Southern California Metropolitan Water District. Our students are, you know, researchers in this lab, work on, you know, separate secure server environments that allows us to work with data that is proprietary, that, you know, can't be openly released. We do a decent amount of UAS, unmanned aerial systems, or drone work. So we have several collection platforms that we use, and also which I teach with in our 5A7 course. And we have a full suite of geospatial software, thanks to our, you know, connection with SSI. And I encourage you all, you know, maybe after this panel, to go to our website, which is at hsgilab.usc.edu. You'll see it on the right here. We're migrating it all to a secure server, so some of the links might be a little strange, but that'll give you even more depth about what we're working on. Can you go to the next slide, please? Thank you. Okay, so I'm just going to talk about three programs that we're running right now. The first of these was with the Aerospace Corporation, which is, as some of you may know, a research branch of the US Air Force. And the issue with this, or what they wanted us to look at, was with drone collection and other remote sensing platforms, you're able to do things like collect high precision, three-dimensional data on dams every single day or every single week. But what you want to be able to do is do a change detection, not even how it changes from day to day, but how it changes from season to season. And it's very difficult to do this intense three-dimensional temporal analysis on these data sets. So I worked with, it was a graduate student and an undergraduate student, and we, mainly using open source libraries in Python, we're able to voxelize or turn point clouds into what looks kind of like Minecraft you see on the right. And we delivered this code and approach to aerospace. And the students and I actually just got back from NASA's Jet Propulsion Lab, and they were interested in using the same code we developed for the next generation of Martian orbiters, because they also want to do three-dimensional analysis of things like asteroid impacts, but they want to be very lightweight. So, you know, I'm excited to say that right now we're going through some of the legal framework in order to provide this for, to NASA and see if they can use it or not. And we're all US government, so it worked out well. And it's currently under review at the MDPI journal, Drones. Next slide, please. All right. So here's another project that I'm really passionate about. We actually have 4 students working on this right now. It's something I worked on at the US Department of State and the US Holocaust Memorial Museum, but it's about documenting human rights violations and corroborating refugee accounts of violence from the area they fled. And, you know, this will help in terms of the UN High Commissioner for Refugees awarding them asylum status or not. So it's critically important. So what we did and what we've developed, and I'm happy to say was just published, is an approach using Planet's daily satellite imagery to detect village burnings in Southeast Asia. There was a genocide that just took place in 2017, and we're trying to really push forward the science and demonstrate to the international community and human rights organizations that they can do this kind of work, right? That's part of our job as academics. And we're also preparing the next generation of people interested in human security, giving them these kind of tools to be able to do this work. Yeah, if you go to the next slide, please. And this is, to give you the full, Dr. Fleming and Dr. Voss, we work on the full suite of human security, and some of that's domestic. So we currently have very close partnership with the Metropolitan Water District of Southern California, which is a huge organization that sells water to everyone that you buy water from if you live in Southern California. And they have a multiple number of temporal spatial projects, and one of these was to analyze how people were transitioning their grass from just happy green turf into drought tolerant landscaping. And we did this writing algorithms on aerial imagery and saw how those changed over time in response to the drought that Southern California recently went through. There's a little more detail about the slide, but it was pretty much another big spatially explicit data set, and we're working on doing high performance computing on aerial imagery to help inform policy. Next slide, please. And I wanted to end with this because the focus of these projects are really on answering research questions that our clients pose for us. But as academics and as instructors, what we also really want to do is provide students these opportunities and to build with them these skills that are going to be in high demand in the next couple of years. They are now, but it's just going to be more so in the future, being able to do computational work with this spatially explicit data. And so what we do is we match our students with the increasing interest of government and non-government sponsors on these projects. You have a picture on here to the right for my research students, or for my research assistants. And I'm proud to say that we've been very successful placing our students and graduates of the lab in all different areas of governmental agencies. We have a lot in DC, but also at the county and the city in California. We're placing students with defense contractors like aerospace. I guess you would kind of call them a defense contractor. And Dr. Voss and I just talked about this, that I'm really proud that one of our recent lab alumni is now received a fully paid scholarship to USC's PhD program in urban planning. So there's a lot of opportunities, and there's a lot of ways to build your skill sets on with these clients. So I think that's my last slide. I'll turn it back over now, and we're going to do questions at the end. So I think Dr. Fleming, I think you're next.
Yeah. So thanks, Andrew, and thanks, Bob, and thanks, Virginia, for the opportunity to spend some time today and discussing some of our programs. So again, I've been around the program here for working on 5 years, and what I've been looking to do with all those that are part of Spatial Sciences Institute is help build out the human security and geospatial intelligence courseware curriculum to include interfacing it with some of the lab work that Andrew just talked about, as we move our program forward. So in introducing this graduate program, as Dr. Voss mentioned previously, one of the things that we've built over the last year is this Master of Science in Human Security and Geospatial Intelligence. So I'd ask you to take a quick read at what we've got here on this particular slide, and then I'll highlight a couple of things for you that I believe are important. One of the things you'll note is there's the certificate that Dr. Voss mentioned previously in geospatial intelligence. So routinely we see many of our certificates as feeder opportunities for students to start with the certificate and then move their way into one of our master's programs that he listed for you previously. The Human Security and Geospatial Intelligence Masters, we see this as something that right now a lot of students are interested in, starting many at the undergraduate level, and then they migrate their way into these types of programs across the United States, whether they be in online programs like we offer it or in residential programs. Where we see our program differentiating itself from others is that we look to, through this master's program, develop students who not only have the technical knowledge to do the work of human security and geospatial intelligence, but also have the leadership and management underpinnings that allow them to work more mid-management in doing things that we recognize are going to be certainly important as the discipline continues to grow. So leadership and management is certainly something that we see that would identify us as a different program maybe than others that you would find currently available to you. So next slide. So how do we do this? Well, a couple of ways. We'll start with some of the enrollments. And we just show you this as an indicator that we're not one-dimensional. We don't just teach folks that are in the master's programs. We see this as a very holistic approach to teaching human security and geospatial intelligence at USC. So what we point out to you on this slide is we have not only graduates that are interested in this work, but also undergraduates at USC. And the reason we point out the undergraduates is that many of them will, if you will, migrate into our master's programs through what are called progressive degrees. So what we show listed here is that we've got a large number of undergraduates that are taking a minor currently in human security and geospatial intelligence. And then currently we're working through curriculum approval right now, a new degree that's going to be a bachelor's degree in human security and geospatial intelligence. We're hopeful that this shows up on the books starting next academic year. But the interesting thing about that is that then becomes the students that then work around and with all the other students that are taking our work at the graduate level, whether they be in the certificate program or in the Master of Science in Human Security and Geospatial Intelligence. So that's just, to me, important to recognize that we're not one-dimensional, we're multi-dimensional in how we see the development and delivery of our program. We use some of the latest and greatest references that are available to us and making sure that the knowledge that we actually put in front of students is current and certainly relevant. So you'll find many of the professions use these things called essential bodies of knowledge in order to help develop and then measure their programs as they move forward. So what you see here listed is this GEOINT essential body of knowledge. This was just released by the USGIF, United States Geospatial Intelligence Foundation. We have a very close working relationship with, and that we use to help create the, if you will, the metrics of what our program should be delivering in the way of content to individuals. And so those types of documents and those types of tools we leverage in building our programs. You'll note that USGIF also has some certifications that they do at the professional level, and then have handbooks for students that are interested in being certified in those types of professional endeavors as tools from which students can do that work. Next slide. So what I'd like to highlight here is our Master of Science in Human Security and Geospatial Intelligence. This program was recently built. This is the first year of offering in the course catalog. And so I'll outline for you how this particular master's degree unfolds. Essentially, as you can see here, it's a total of 9 courses, 5 that we call the essential courses, 3 that we call the advanced courses, and then finally there's a capstone course. When you look at this, there's the first 8 courses that are taken. The essential and advanced courses are all courses that are essentially considered full load courses, and then the capstone course requires you to have many of these other ones completed. Specifically, the essentials have to be completed before you can take the capstone course. So in the essentials courses, you'll note that there's 5 of them. The one that I'll spend a little bit of time with is because we recently developed it as a required course that's necessary in order to get this degree. It's the 577 course. The title of that course is Human Security and Disaster Management. And so that course is designed to provide the HSGI baseline content that's necessary in order to do what I call chaos management. So when we think about chaotic conditions that the world unfortunately faces routinely, which often translate into insecurity, and then, as a function of insecurity, we see instability. And that instability word is, important to recognize. Dr. Marks previously mentioned that we address through the lab human suffering, or this idea that when folks have to have someone else stand up for them, in some cases because they can't stand up for themselves, or in some cases they just can't stand up anymore. And I use those words kind of in air quotes, but I think they're important. Routinely, we see these types of suffering conditions around the world where there is tremendous instability, often linked to insecurity. So this course 577, Human Security and Disaster Management, is that baseline course that helps you understand where this occurs in the world, and often linked to natural disasters, so disaster management. And we use many scenarios of natural disasters from which we experience around the world, and then how skill sets in geographic, in this case, geographic science and technology courses, but specifically GEOINT, help those that are working through these types of problems, help them manage the problem, manage that chaos. The other courses that you see there, 581, ideas of how to think spatially, 587, which is routinely seen as a really fun course for students because it has an experience on Catalina Island as a way of collecting geospatial data. 588 is a remote sensing course, and then 579 is the tradecraft course in GEOINT. We consider those the essential courses. And then when you move those courses to the next level, the advanced courses, the two that you see there, 585 and 578, again, leverage this idea of building students that can both manage and lead organizations using essentially that essential knowledge that we believe is important. So 585 is a management course and 578 is a leadership course. And you're required to take both of these as part of this degree. We do provide some flexibility for the students by taking an elective. And that elective could be in anything from more data collection to data analysis, or possibly modeling, and even geovisualization, creating the products on the back end. But we ask the students to pick something that they're interested in that different level of, or those different domains, in order to be able to strengthen where they believe they're going to make a difference with this degree. Once those are completed, then we ask the students to take a capstone course, which is a project-based capstone course, not a thesis-based. But what we find is we build projects for students, and we'll talk about who we build them with in the next slide. But the capstone course is designed to require students to analyze and then work through a real-world problem that is either government-based or industry-based, that then they have to work together as teams in order to create a solution as part of the capstone course. So next slide. And who do we do those projects with? Well, again, we create a collaborative network of folks to work on those projects with. Some of these you've already seen as agencies that were mentioned earlier by Dr. Voss. So Unigis and Esri and NGA, USGIF, you see those as many of the players. But then there's a large suite of folks that we work with, mostly from the LA Basin area, but actually we've extended that back East Coast to some of the other organizations that are working in the GEOINT field back on the East Coast. But you'll see a lot of these from the industry partners that we work with and helping to build projects for students. Dr. Marks already mentioned aerospace as one of them, so you'll see them there on that list. And then we also do work collaboratively across campus. So Dr. Voss mentioned earlier that we work very nicely and friendly with a lot of the different organizations on campus. We see this as how to solve wicked problems, and that is through a collaborative approach through many academic disciplines. And so you'll see there a listing of many of the organizations that we work with in handling some of these projects on campus within the USC architecture. This top one there, USC Institute for Creative Technologies, is an organization that both myself and Dr. Marks are affiliated faculty with, and they do a lot of interesting work with primarily the U.S. Army, but other organizations that are linked to DoD with a lot of modeling and simulation for solution sets in creating some really interesting problem solutions to what we see GEOINT as being something that is going towards in the future. So hopefully that's a good breakdown of some of the things that we're doing, who we're working with, and why the program is built the way the program is built. So if we go to the next slide, I think I'll turn it back over to the team.